Okay, looks good. This is the 2025 Design and Tech Report. Thanks for tuning in. Here we go. It is called Autodesigners on Autopilot. And like all reports, they're an attempt to connect in different spaces. We got the business thing, you got the design thing, you got the tech thing, and you got this dark AI lagoon thing right now. I'm not sure if you feel that. And what you have is you have greenfield opportunity, and you have startups blossoming all over the place. Exciting time. All right, so when I prepared the title, Auto Designers and Autopilot at South by Southwest, people thought I was going to do a presentation on cars. Nope, wasn't that. This is Sora, by the way. It's amazing what we can do now, what we couldn't do a year ago. The report is something I make by taking a year's worth of bookmarks, stacking them up. I tried to use GPT-4o to analyze all my bookmarks, and it did it in 25 minutes, and I was like, whoa, pretty amazing. But I did the old human fashion way. I did it over maybe 20 hours every night on the weekends, etc. And I got through it. And I'm a little delayed because I got a little bit ambitious. I'm going to make something called the Design and Tech Report Coach. It's going to be a little mobile app. If you are interested in it, please let me know in the comments or whatever. I'm not sure if it's a waste of time, but I learned Flutter like when it came out, and I love Flutter. So I'm just going to sort of build a mobile app, and we'll see how that goes. If you want to try this out, let me know. Okay. So the key takeaways for this year's Design and Tech Report: no worries, AI is not replacing designers. It's transforming how designers will do work. The agent era is here in a big way. AX is important. That doesn't mean just adding agents to the user experience. It means making a user experience for agents, the AI's UI, basically, which it turns out it doesn't want UI. It loves the command line. It loves manuals. It loves APIs. Does it need a drop-down menu? Not really. And in this world where AI will move things faster, we got to think about responsible AI. And lastly, you got to be adaptable as a human because AI will augment the future. Great. And we have to adapt while this happens. Now, the biggest adaptation for anyone who studied statistics knows that statistics is for wimps, and calculus is for cool people. When I went to college, I learned calculus because that's how you do, that's how you figure out brakes, all the mechanics of a car, a missile's trajectory. That's real math. But statistics, no, that's for wimps because you don't have enough data to power interesting statistics outcomes. It's all kind of imagined in equations, well, pseudo equations in many cases. And I was at Austin Hilton looking out from my restaurant, and I was like, whoa, what is this spelling over there? I think I know what it means. I, the human, knows, but I wonder if GPT-4o Vision knows that. So I punch it into GPT-4o and ask what the sign says, and it says it thinks it's Courtyard Marriott, which is pretty cool. The key word, however, is this word likely. It thinks it is that. It thinks it's likely because, let's be frank, maybe they rebranded as CORTYRD. They'd be cool. We don't know. It doesn't know. It's likely. Now, in 2018, I surveyed visual designers and product designers as to what they thought AI would do in the future. Around 2018, I got a little tired of AI because it was trending and trending and trending, and I thought, well, it's going to come eventually. And so here is a poll break for you, if you'd like to weigh in on what you think about this topic. And I will show you the results here later. But if you can add your poll results to that, point your mobile to it. It's like 2 questions, and let's keep going. Okay. So William J. Mitchell wrote this book called The Reconfigured Eye. It's out of print. It's from MIT Press. It's a wonderful book if you're worried about this age of generative images, because it turns out that we humans are quite clever. This is a photo from 1863. It is a Confederate soldier slain. And then there's another photo of the same era. This is a Union soldier slain. And it was pointed out that this picture is the same person, and the photographer wanted to sell to two markets. So it's an example of a reconstructed image, the reconfigured eye, as William J. Mitchell described it. And this book is really important if you, I mean, it was before all this cool Gen AI imagery, but we humans are really good at manipulating the truth with not just photographs, but also illustrations. If you look at this book, you'll get what I'm talking about. It's profound. And I want to give us a warning from 1970, Marshall McLuhan. He was a Canadian media philosopher. He warned us that the politician will be only too happy to advocate in favor of their image, because the image will be much more powerful than they could ever be. So this media is the message, is an important, the medium is the massage, or this sort of combinations of words. I kind of didn't really care about it when I was younger, but McLuhan's work is super important, especially in this new day and age where, my gosh, there's so much media. Now, a long time ago, I was the everyone should program person, and I created this system called Design by Numbers. You can make a white rectangle. Not impressed, are you? This is a black rectangle, maybe more impressed. You can make a 33% black rectangle. I have 20 chapters in this book, and chapter 1 is just set in the paper, and you're thinking, wow, that's pretty boring. Well, check this out. Chapter 2 is set the pen color. Now I hit play, and you're like, whoa, it didn't change at all. Well, let me change that to pen 0. Whoop, looks the same. Well, in reality, in the computer's brain, it set the paper to 66. It set the pen. Its hand is like in the air right now, ready to draw, but it's not going to draw yet. That's chapter 2. And chapter's 2 point was to say, there's stuff you can see happening on the computer, and there's stuff that you can't see happening on the computer. We only see like a tiny, tiny fraction of what the computer is actually doing on the screen. It's actually doing a lot. Now let's draw a line, because that's sort of what we like to do when we set the pen. That's chapter 3, a little more gratifying. I can sit here and draw the Mona Lisa if you are bored and want to watch me do that, but you probably don't want to see me do that. What's fun about the line is I can stick it inside a forever construct, and I can draw a line from the origin to the mouse position. And what you get is, voila. It's sort of an interactive thing, and I can, furthermore, add a fresh piece of paper in between the forever refresh, and look, I've got a rubber banded line, right? And that's all with interactivity. Now, this was a grand attempt by me to teach computer programming to anyone in a 100 by 100 square, only in black and white. And luckily, I had 2 students who told me that was a bad idea, and they went off and made processing. So just for some history, I began my journey seriously with Code Warrior. It was very cool. There's Design by Numbers, led to processing, Arduino, P5.js, Scratch, open frameworks. Anyways, a lot of stuff happened, right? And we're here today. I want to thank RGA for discovering the gulf of design and technology. Oh my goodness, right? And in this gulf, there's an exciting moment where designers create with UI, and I think of it as we make obstacle courses for the user. But in the AI era, you can actually teleport to the goal. So what does it mean? Well, UI is a kind of obstacle course today, and really, this is under question, because if the user doesn't need it, the obstacle course, and they teleport just to the goal, what happens to UX is a question. Now, let's think about open source AI for a second. In the 2018 report, let me show you the results of the survey. Let's see how many people are going to change this. But when will AI replace most traditional visual designers? Never. Nice one. 2 to 3 years from now. Okay. When will AI replace most digital product designers? Never. And never is getting a little shorter there if you noticed that. When will AI replace most designers? This is a person who is not from the design profession. Never. See that? A lot of romance there. Yeah, let's believe that. Okay. And open source AI. In 2018, I measured the number of GitHub repos. I just searched for it. There were 94,000 machine learning repos, 28,000, 10,000 AI repos. In 2025, there's close to a million, 300,000, 1.7 million. So what does that mean? It means that there's never been a better time to code with AI because there's so many repos out there for you to learn. So it's a really exciting time. And also, it doesn't cost a lot to experiment with AI. It's relatively cheap. For instance, just last year, you'd pay this much for GPT-4. Now you pay this much for GPT-4o. Notice $30 compared to $2. Not bad, huh? And the idea of reasoning that was introduced by the O1 model from OpenAI, it was expensive, but now the little whale, the DeepSeek R1, has shown that you can do that cheaper. So 2025 is all about, maybe what you talked about AI models, just stop saying models and just say agents. Just stop yourself. Do replace all agents, models to agents. And AI is entering an agent era. This loop thing is sort of coming to the foreground. I'll explain why. Well, it's because the cost of tokens has gotten so cheap. And don't forget, conventional computing without AI is powered by loops to make them powerful. Think any service out there. The loop makes computation powerful, and the loop is making agents extremely powerful as well. And this year, there is the book I wrote in 2019 is making a comeback. It's called How to Speak Machine, A General Introduction to Artificial Intelligence. There's just 6 chapters that lay out the foundations of computer science and AI. And I thought I'd use that to guide this year's report. Okay. So it turns out I made the whole report and I discovered that all the important stuff I had sort of removed. So this is the most important stuff. And if you want to stick around, oh my gosh, this is kind of long already. If you want to stick around, you'll know more things, but this is basically all I think you really need to know. First off, AI UX is changing things. If you want to look at the basics, I have a course on LinkedIn. It's called UX for AI Design Practices for AI Developers. And there's just 5 things to know. Post AI notices, hey, this is AI generated. Suggest next steps. Hey, why don't you do one of these things? Show tight citations. This is where it came from. Provide status updates when it takes a while. I'm going to take a while. And also be open to feedback. It's like in the bathroom, there's that sort of smiley thing. You can say, give feedback on the cleanliness of the bathroom, so the AI wants cleanliness of its completions, right? So giving feedback is useful. I think the whole AI UX stuff began with the fascination with semantic zoom or pinch to zoom. Harley Tarrant, I think, is the first person I saw take this kind of seriously. I know the Arc browser did this as well, but the guys stuff is so cool, right? And so pinch to zoom is similar to, on a map, you can pinch to zoom, but you can do a semantic zoom with large language models. And this is quite cool. This is when OpenAI introduced to the world O1 reasoning model. And I thought this design of showing it thinking and showing the reasoning was super cool, a new way of showing the AI's inner thought process. And I think that pattern is here to stay, if you've seen it. Also the planning patterns as well. These are all part of the model, thinking more deeply, also called, just a few years ago, chain of thought reasoning type of thing. And there's a great video with Raphael Schad out there by Y Combinator. And Y Combinator has a whole AI sort of review with Raphael. And I recommend you watch it because there's all kind of great patterns in there. Here's some practical wows I've given a trophy to. I love this idea of a website where you can pick short and long, which in the past was kind of hard to develop, but now, the LLM can go blah, blah, blah long for you, or it can go short for you too. You can put that into your website now. Also, Nick Dobos is the person who I saw call this context decorators. I like that. For instance, in Cursor and GitHub Copilot, whatnot, you can include a pointer to the file or a pointer to a directory. This is a great way to kind of ground your prompt. And this context decorator sort of tells the model, hey, look at this context. I made a few demos for this year's Design and Tech Report using P5.js. This is my selective text editor. So sometimes it doesn't work, so caution. But anyways, I select this, and let's say I want just that part of the thing to be more formal. Come on, go ahead. Is it going? There it is. Okay, so, well, that's pretty formal. Or I can take this text here and I can make it simpler. And so it's basically pointing to something and then having the LLM work on it. Oh, it actually did work. It's so fast. Oh, there it is. So you see, I can choose something and apply the prompt. Anyways, that's a cool technique you see everywhere. Also, version control is really big because these things generate so much. I think Jeffrey Litt has the best thoughts about that. On the image world, this is some wonderful work by Pablo Stanley. This is a really cool sort of like a equalizer in 2 dimensions of different styles. Oh, so cool, isn't it? I love Pablo Stanley. You'll see more of Pablo Stanley in here. I'm a fan. This is a Mad Lib style approach. I've seen this used more often now. Style, subject, and it's kind of nice. This is by Google, their Whisk tool. And again, there's just more approaches to regional image prompting. You sort of pick a part and sort of like have it do something. Recraft has vector, has SVG. Disclosure, I'm an investor in Recraft. There's just so many great ways to sort of like work in the graphic domain now, and it's just going to get better. There's something the young people are calling malleable software. It's existed in the research community, I found, but this is really cool by Atlu. It's taking 2 apps and kind of like mating them, and it creates a brand new app. Oh, that's really nice, isn't it? And I made my own little demo here because I wanted to see a concept I've been wanting to make for a while. It's called the semantic eyedropper. The way it works is I can take that paragraph and I can drop it in a petri dish and sort of reproduce it. Or I can take this global food system one and mix it with this petri dish. Or I can take this quantum thing and drop in the food and AI one. So anyways, it's an example of how you can really do odd things with semantic world thinking. All right, so there's 4 AI UX spaces. So what did I show you just now? I showed you different patterns. There's not that many patterns. They all look kind of the same. They're sort of playing with semantics or they're playing with space. And so this is an example of 4 spaces. There is chat AI UX. This example I made because there was this sort of meme online that it's so easy to tell if it's an AI or not because you're just like taking turns. Not true. So you can do things like, hello, I'm feeling awesome. How are you? Now notice that I'm just like talking and it's sort of waiting and it's sort of like pitching in and now it's like, whoa, so cool. So you can see that this pattern, we could really fake it very quickly with AI. So AI chat is anything you want to design with. A few other things I've noticed. You can chat with a lot of agents. This is a nice piece by Helen Armstrong on visualizing uncertainty. You can chat to an entire society of humans. It's a new Y Combinator Societies startup. It's sort of like talking to SimCity. This is Alexander Chen. I loved this when this came out.
Move them to the top. Move them to the bottom. Put them back in the middle, but swap red and blue. Can you make yellow?
Goes on and makes a snowman. It's very cool. So just check it out. 2 of 4. This is document. So that was about chatting with AI. This is document revolutions. This is Tyler Anger. Got some really good stuff about. He was talking about like writing something and the LLM can like sort of start to kind of build a tree of knowledge around it. I thought I wanted to try that myself. So I wrote this thing, the Semantic Concept Explorer. And I can give it any text and I can ask it to analyze that. And it pulls out the salient, sort of hard to understand stuff. And there they are. And I can just sort of do a deep dive in that. I mean, pretty cool, huh? I'm a little shocked that I could make that like in 10 minutes. Bizarre times, folks. This is a color picker for words by Matthew Shu. You know, semantic can have a kind of a color to it, a tonality to it. I thought this was quite clever. And then Jeffrey Litt has some very sophisticated things. This is a planner system / map system / like a reservation thing. So there's weird apps sort of forming, and where the carcass is, well, the carpet, the corpus, whatever you call it, the sort of main body is a document, but it's turbocharged. And let's see here. These are some things I found. String cheese paragraph, zoomable news, extendable articles. There's some really good stuff on content, so definitely check it out. Number 3, there is tables, and tables are really cool, aka spreadsheets. There's really interesting work out there, answer grid, elicit, and I made my own example of this. So this is a AI-powered text spreadsheet. So the way it works is I can change the quick brown elephant. And when I hit return, it propagates to the cell that's using it, and there's an equation for it to translate A1 to French, analyze sentiment of A1, combine A1 and B1. Pretty cool, right? So this is an example of when you put this stuff in a table, it's really powerful. And we'll get into this later, why this table representation is next level. And lastly, the canvas space is the other space, sort of a free-form 2D space. This is Samuel Timbo. Like, this stuff is like, I remember building these kinds of things a long time ago, but he's taken it to a whole different level. It's like a visual programming system. And Amelia Wattenberg is a wonderful design engineer, and this is her email decomposer. So she can read all her emails as a 2D infinite canvas. It's beautiful. And if you were under a rock, you've missed the TL Draw revolution. Oh my gosh, this is amazing. And here I'm using Obsidian, which I love. And Cloud Artifacts, ChatGPT Canvas are the kind of main approaches to this canvas thing. And if you love this kind of stuff, check out Char Styles, MIT Media Lab Thinking with Sand Talk series. This is all these cool free talks by some of the coolest young people out there. Okay, wow, we're at 24 minutes. Okay, let's go. I may cut this into pieces. Okay, this is chapter 1 loop. Again, I'm using the How to Speak Machine chapter format. I have 6 chapters. Let's go. Okay, so this is Char Styles. She's going to dedicate her thesis to loops. I believe that this is so important. Everything is about the loop. The loop is what gives the computer power. That's why it's chapter 1 in How to Speak Machine. It is an unnatural capability of a computer. And I remember my first computer program on the Commodore PET. It was this program, and I want to recreate that moment for those of you who have no idea what I'm talking about. So the computer used to work like this with a green screen, and you would say 20, go to 10, and you'd sit there and hit run, and it was like, oh my gosh, this is printing it forever. And it was a nice feeling. But after you do that, my friend showed me this, and I was kind of like, oh my gosh, you just do the same thing, put a comma there, 10, and run. And it's like, whoa, amazing. And I was just stymied by how this thing would just sit there and print this, and it would, like it never got tired. And you'd come back like an hour later and it's still doing it. And so this computer is very strange. It can do these things forever, basically. If you think back to design by numbers, the forever command is something that I think I may have invented. So it made its way into Scratch. But this forever theme to me has been really important in my own journey and with computation. Okay, let's talk about an agent at rest. I'm calling it at rest for a reason that'll make sense in a few seconds, but it has a model, there are prompts, it has knowledge for extra grounding, and it has tools. It can call APIs. So an agent can sleep, so it's an agent at rest. It's not doing anything. It's like a command. It's a .exe. It doesn't do anything. Or it can loop. It's a service. It's running and running and running and running. Now, it turns out that we couldn't afford to run agents and loop back in the GPT-4 era because it was expensive and there wasn't that many tokens available on Earth. So now the tokens are cheaper, so agents are running in loops, and they're extremely powerful. Think of how FTP was kind of yawn, yawn, yawn. Oh, I can transfer a file. Big deal. But with the powerful servers run in a loop, it becomes a web server, right? Serving data, serving files 24/7, continuously at high speeds. And there you have it. Power, right? So agents at rest for the early years are now running in loops. And that's why we're feeling this agent era right now. Agents are very similar to object-oriented programming, I believe. When object-oriented programming came on the scene, for many of us programmers, we were like, what is this? This is so confusing. You have classes. What is that? You've got properties. Huh? You've got methods. Oh my gosh, inheritance? That doesn't make any sense. So in the same way, you've got models are the core, you've got knowledge or the object properties, you've got APIs or the methods, and you have these fancy ways for reuse. And I think it's just this, it's what Tim O'Reilly says, it's not the end of programming, it's the end of programming as we know it. That's not new. So those of you who were there during the object-oriented programming era, you know what I'm talking about. Those who weren't are like, what's he talking about? So that's okay. An agent in a loop, I think the best analogy is a spreadsheet. Oh, spreadsheet. One sec. Sorry, I've been trying to do this and I haven't had time to run all my stuff. So apologies. There we go. So like if I make this 500, do you see it propagating? I make this 7, I make this 100. Do you see it propagating? It's not really propagating. This cell is running in a loop. So this is basically an agent. This is an agent. This is an agent. And there's handoff. Look familiar at all? That's because it's running in a loop. Running in loops are the most powerful things we can do with computation. Now, look at this. In 2023, Vivian Wang, oh my gosh, she's so amazingly smart. Lillian Wang, agent equals large language model plus memory plus planning skills plus tool use. And that was back then, because remember, GPT-4 tokens were expensive. And now their token cost has dropped. So if you look at all the door number 2, agent is LLM plus memory plus while loop. Door number 3, loop, and that's just because tokens got cheaper. Hey, did you know that Steve Jobs actually said the next stage is going to be computers as agents? He did say it in 1984, but anyways, oh my God, that guy. Okay, art is how we see the future, is what I've always believed. In 1993, I made this image. It was recently sold in London. I had like a couple of these. I made it with display PostScript. and they're super high res. It's 50,000 loops. And again, it's because I've always been fascinated by loops. Example of, it's like this drawing. It's like it's never going to stop. I remember my professors in Japan, when I did this, that freaked them out. They were like, can you stop this? And I was like, no, the whole point is you can run them forever. This thing is over here. And I like how Jordan Singer recently said, I like what I noticed about cursor is a symbol for agentic behavior is infinity. Here it is. But like I said, until tokens got cheap, it wasn't infinity. It was super expensive to run them just once. When the costs of technology go down, we introduce a loop. The loop is the most powerful aspect of computation, and that's again why it's chapter 1 of How to Speak Machine. Now the command line's made a resurgence, and those of you who have never heard of it, young people haven't heard of this one. Neil Stephenson, in the beginning there was the command line. And he wrote this wonderful essay about how GUIs destroyed the power that we had with the command line interface. We surrendered the power, he says. And what does that mean? Well, we kind of got it back. We have this thing called chat, right? And so when you think about like LS is how you look for files, and you might say history or something and it doesn't know it, but that's basically like typing into chat, like hello kind of thing. And that's like command not found. So really we've kind of brought the command line back with this powerful large language model processing. So we've kind of like left the GUI again and came back to the CLI. And that's where terminal UIs are making a comeback. And if you've ever typed banner at the terminal, oh my gosh, this is so good, because paper used to be connected end to end, and you can print out a gigantic message. Oh my gosh, I love typing banner. There's all kind of, the young people are making terminals. I remember when Fig was acquired by AWS, but there's also Warp, and Ghost TTY is a new one. And there's things called terminal UIs, TUIs. There's a whole GitHub awesome TUIs. I love this terminal.shop. You can order coffee with an SSH and you can order. This is like amazing. Gosh, the young people can do all this stuff. It's incredible. So you can actually do this all from the terminal and order coffee. It's a beautiful interface, right? Okay, and with CLI, you need a monospace type. This is by Helena Zhang. It's a beautiful monospace typeface. And also GitHub has upgrade to monospace. And this is by Abby Foreman. This is a RISD graduate, but I like how she's taken a ASCII approach to a web page, and the little red parts are basically like hyperlinks. And this thing's adorable, isn't it? And this is kind of like MySpace-y, but again, it's a different, simpler aesthetic. Sam Dape has some of the most beautiful things I've ever seen. Oh my gosh, this is his TextOS group example, but you could definitely check out his work. And just want to give a shout out to Sacred.Computer, Monospace Web. They are React componentry for monospacey things. Autopilot was invented for airplanes in the early 1900s. You may have heard of the DARPA Autonomous Vehicle Grand Challenge. This is what led to today's, I guess, Tesla Autopilot and things like that. Autopilot was always hard back then. It still is. There are sensor issues, there are navigation risk, harsh conditions, system complexity, like, what happens if a sensor sort of like breaks up? What happens if the traffic is super complex? What happens if the weather is really bad, the sensors are all failing? And then, of course, legal and ethical concerns, like what's okay? And when we see all these like humanoid robots, we have to remember that the car is like the first major robot we ever brought into the household. And the car is dangerous. I mean, whether you're sitting in it or if you're sitting outside it. So the Society of Automobile Engineers, SAE, have these different levels. And for the life of me, when I was hearing about Tesla, Autopilot, blah, 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 level 3, I was like, what are they talking about? It's just this SAE index. There's different indices. Level 5 just means like super duper sentient driving. People keep promising that. Turns out it's pretty hard. Level 0 is the one we're used to. Level 1 is when you have cruise control. Level 2 is when you have cruise control and lane centering. I guess more cars have that now. Level 3 is kind of human in the loop. But anyways, it's a different way to kind of think of autopilot. And when LLMs were autopiloting computers, I think Open Interpreter was the first one I saw that did this, and I was like, oh, I'm a little bit afraid because I'm asking it, can you delete all my files? And I was like, it said, yeah, I can do that. And I was like, oh, maybe I'll turn this off. But there are many ways to do this now. It's called computer use agent or something. There's an OpenAI operator. There's these cool YC companies. If you haven't tried Stagehand, I thought that was really cool. There is Scrappy-Bara and now Pig for Windows, and Claude Code gets all these nerd bingo points because it's CLI and it's like software engineering agent. I just saw a highlight up here on the grid, different ways to control your computer. Anyways, don't lose control because it's not a good thing. The International AI Safety Report just came out in 2025. It talks about loss of control can be one of active loss or passive loss. If it's active loss, not good, because that means someone could be coming after you, or it's unintentional, you just forgot. And passive loss is you just forget and you get lazy. So I follow the sophist Linus, and I noticed he said that he recently built a chatbot that eagerly executes its actions without any human approval. Brave person. So if you think about it, the green check marks mean, hey, gave up control, gave up control. And the X means, luckily he hasn't built a system that's adversarial against himself. But when you give up control, you got to think about it. Now, if you heard of MCP, it's been trending in December. I remember over the winter holiday season, I was using it and I thought, wow, this is pretty cool. And I like when the young person said, isn't MCP just an API for APIs? It's powerful to give the agent APIs. There's tons of them. And this is a text user interface for OpenAPI that I thought was unusual, because if you see all the APIs you can access to, you give these to an agent. That's pretty amazing. Now, think of why giving tools is important. Think of your computer for Gen X people. Remember when there was no network? The computer couldn't do anything. It was kind of useless. But by having tool calling, you get to call APIs. And so think of a foundation model as living in the confines of its thinking. And however, if you can do tool-enabled AI, you can connect it to different things like weather, database, search, whatever. And what it means, quite simply, is let's say I wanted to ask for the weather to a foundation model. It wouldn't know what that is, but if it's equipped with tools, it can go out and fetch the weather. Whereas in a regular LLM, you'd ask it for something and it would say, I have no idea what that is, because it's stuck in its own confines. So tools are super powerful. And if you think about it, for Gen Xers, there was something, if you remember the web in the early days, there was something called CGI, not computer graphics imagery. The Common Gateway Interface was the way we were able to reach out and call different services. Those of you who remember it, it was a really big deal. So I think MCP is the same moment for the new generation that we had when the web was rising. The problem with tools, like calling an API, is it's very powerful. When it's read-only, it's safe, but when you can do write actions, it gets pretty scary. So there's risk and reward when you use tools. Now, when we think about the risks, this is a chart. Without tools, it's limited to certain outputs, maybe text and image, you have to do manual work, very, very low security concerns, you're easy to control, and potential harm is low. Whereas agent with tools are more powerful, AI can act independently, it can trigger actions, it's harder to monitor if there's a lot of these requests being made. It lets you move faster, but potential harm is high. So just think about that when you give your agent tools. And if you're worried about this at all, no worries, because I have created a course on LinkedIn called The Art and Craft of AI for Business Resilience, Let's watch the opener because you'll see why. Risk management in AI isn't just about playing defense, it's about going on the offense too. With AI, we stand at a crossroads today. Will it pose a challenge, or will it emerge as our champion? This course navigates through both the shadows and the shine. Guided by wisdom from my former colleague, MIT Professor Yossi Sheffi, and his encouragement to be risk-versed, not risk-averse, we dive into our AI Crafts Corner, crafted just for you. We're taking a risk by trying to engage your hands, mind, and heart. I had a lot of fun making that, and I want to thank the LinkedIn crew for doing that. I love getting back to clay. So if you're interested in how to manage risk with AI, that course is for you. All right, chapter 2, here we go. So first was loops, now it's large. And the inspiration for How to Speak Machine was this interview with David Bowie about how he was asked about the internet, and the announcer was saying, oh, it's not a big deal, it's just a tool. And David Bowie says, no way, it's going to change everything. It's like an alien life form that's landed on Earth. And wow, he was right. And he could have been an alien. And the best way to understand this alien world, I think, is Netflix Stranger Things, that TV show, where there's this notion of the upside down world. And this is by Joel Simon. I think it's kind of brilliant. It's a multi-person latent space visitor. And what is latent space? Well, it's a different dimension where we can visit and we can come back from if we're lucky. And latent space, when you think about it, is just higher dimensional representation, which I want to use compression as an example of what that really means. So some of you will remember GIF compression or GIF. I'm not into that whole debate. There it is. Okay. So the way GIF compression works, it depends on having flat areas of constant pixels. So you can compress them as like, there's 100 reds, 100 greens, and it really is efficient compression. But if you have a lot of variation in the image, it can get very large, actually. And so GIF, graphic interchange format, was good for images that were from computer graphics systems, the primitive ones with flat backgrounds. And so JPEG was invented to use Fourier transforms to really kind of take it to a whole different level. So this is the original image here, and it's converted to frequency domain, which I think is the upside down world. And you see on the right here, it's been, the red means the frequencies were canceled, and this is the result. When you go back, you go from here to frequency domain, and you convert back. You can see the image isn't that good. Here's where I'm removing more frequencies, and you can see, oh, it's lost quality, so-called lossy compression. But this domain always fascinated me. It's a frequency world. So this world is like, you look at this picture here in the middle here, I don't know what it's, you look at this and like, oh, figure this out. And like, oh, what is that? But over here, you can see it as reality. So taking something, moving it to frequency world, basically like a higher dimensional space, kind of, right? And then bring it back to the real world. These models that we work with, they work in this kind of weird world. This is sort of similar to latent space. And because of it, it's kind of hard to understand. That's why it's taking a while for people to kind of adopt to it. So this is something I was keeping track of in the Design and Tech Report. It's a phrase said in different eras. And in 2012 is when GPUs sort of crossed over and became something that would really power the new revolution of AI. And it was speech recognition and speech synthesis that experienced this early on. This is in 2015 how iOS Siri would talk.
1 fluid ounces. 1 liter is 33.81 fluid ounces.
And the next year,
1 liter is 33.81 fluid ounces.
it's a tiny bit better.
1 liter is 33.81 fluid ounces.
And it's like, wow, that 1 year just jumped, right? So that was the revolution occurring. This is OpenAI Alloy talking in 2024.
1 liter is 33.81 fluid ounces.
Very chill. This is the top of the line open source model, which probably now is sort of superseded by some other model. Oh yeah, Sesame went open source.
1 liter is 33.81 fluid ounces.
And this is Sesame's model.
1 liter is 33.81 fluid ounces.
Can you say it in a way that would surprise someone that it's coming from an AI?
You won't believe this, but 1 liter is 33.81 fluid ounces. Mind blown.
Can you say it again?
Okay, brace yourself. 1 liter is 33.81 fluid ounces. I can say it again and again if you'd like. It's kind of hypnotic, don't you think?
Pretty amazing. And now there's an open source version of that model. So when you think about models, let's talk about latent space, embeddings, higher dimensional stuff. This is like an old piece by the Google team, or the PyTorch team. And I've always loved this, or it's a TensorFlow team. I get these mixed up. Sorry, people out there. I know it's like a religious thing, but this is a word to vector system, taking a word, computing a vector, or there are vectors, and you can compare the vectors in space. It's reducing dimensions to sort of see proximity. And it goes to this metaphor that Herbert Simon had, that intelligence is like two blades of scissors. One is cognition, one is context. So embeddings are how we get the context right. Because there's three kinds of models. There's the completion models, the embedding model, and diffusion model. I just made these demos to see how to explain that. Okay, so let's say I'm going to type I, and it's going to guess a word. Or maybe I'm going to, I am happy. Oh, I'm happy too. B. Oh, that's pretty good. So let's clear this. I am John Maida, and there we go. I am the, oh, well, it can't predict me anymore. President. I was a president. I am the president. Oh, I'm not the president anymore. Really? Oh, what are you going to say I am? Oh, I was. So wrong prediction. Sorry, GPT-4 Mini, but it's basically predicting the next word, and that's how these completion models work. Then there are embedding models. And embedding models compute the position in a higher dimensional vector space of a word or phrase, sentence, paragraph, etc. Here we are. So these are the words dog, cat, bird, fish, tiger. They're being placed in vector space. This is actually reduced, and it's not quite accurate, but you can see here, this is dog. Dog is the same as dog. Dog to cat is 60.3% similar. Fish to dog is less similar. I can do a semantic search, and I can say I want to look for a kitty. Kitty is very similar to a cat. If I look on the map here, it's dropped it over here, which again, it's in higher dimensional space, so it's not that accurate like a map. But if you look over here, kitty compared to tiger, 40.7%. Kitty compared to cat, 58.8%. Compared to a dog, 41%. So this is a similarity measure, really. And the neat thing is you can apply this to sentences. So it's computing sentences and which sentences are similar to each other. So, and it gives you a number, a scalar number. So pretty amazing, right? Actually, scalar number isn't a correct phrase, but scalar is a number. Okay, let's keep going. And lastly, diffusion models. Diffusion models are the image models, you know, like stable diffusion, etc. This is a simulation, but I think of them as models where you squint, and they gradually have been taught how to turn noise into images, and over successive iterations, they find the right image. And does this work? Does dog work? I forget. Dog. Well, anyways, this is an example of how it works. Noise becomes image, and that's how image models work. And then there's this weird thing that came out just a week before South by Southwest. It's called a diffusion large language model. where the words, the paragraph, the entire page just kind of like squints into view. And you just got to check this out yourself, but pretty amazing. Chapter 3. Okay, how are we doing here? We're doing on time? Okay, well, here we go. There we go. Chapter 3, software is alive. I've always felt this. And because it's alive, it is both powerful and unpredictable. That's from How to Speak Machine. In 1993, I made this thing called Illustrandum. It is an implementation of Adobe Illustrator. That took so long. I wish there was vibe coding back then. But I built Illustrator, and then I want to show how I could select a point. And when I select a point, I can sort of let it kind of like wobble around. So this is super low res, but you can see it here. I'm selecting a point, and I can turn on the randomization of it. And now I'm cranking it up. And really, I remember in this era, 1990s, I showed this to my professors, and they were freaking out. They would say, oh, what is this? This is so stupid. Stop doing that. But it's where I got this feel for computation as hinting at a world where graphics are alive. They will react. And so I called these reactive graphics in the early 1990s. And when AI declined, I worked in AI in the 1980s, and then it segued into artificial life. And there's something called Conway's Game of Life, which has 4 rules, 1, 2, 3, 4. And when you apply them to a grid of cells, it's weird because if you apply those 4 rules to these pixels here, it'll morph in the next iteration to this, to this, to this, to this. It forms what's called a glider, which means these individual cells are rules, but it can take these patterns with these local rules, and you have what's called emergence. So this is an implementation of Conway's Game of Life. Again, any motion you see here on the grid it's not programmed. It just emerges from the simple rule of the cells. Isn't that wild? So cool. Again, this took me like maybe 10 years to appreciate. So if this is boring to you, I'm with you. But it took me a while. Now I'm like, whoa. But back then I was like, what is this? This looks kind of like this is boring. Okay. And another implementation of this artificial life is the Bratenberg vehicles. And this is a robot with 2 wheels, left and right wheels, and 2 sensors. And so let me show you it running. And it turns out that with just these 2 wheels and these 2 sensors, you can simulate fear. Let me put some like, see there, it's afraid. But this is very simple mechanical rules, mind you. And if I just change the rule simply to the sensor mapping, it becomes love, sort of like hanging out with these things. And again, that isn't a program behavior, it's an emergent behavior. But definitely check out Valentino Bratenberg Vehicles. It's a really slim book. I don't think they sell it anymore, but really nice book on artificial life and very simple robots. This is a beautiful work from the early 2000s that most people don't know about anymore. This is a chair that sort of like reassembles itself. That's pretty cool. And so-called robot chair. And I think there's all kind of really cool things now. This is the Jizai arms from the University of Tokyo. They're like Dr. Octopus arms, really working. If you have a free time, check out GP-TARS. It's a TARS robot from Interstellar that has GPT voice. And there's tons of humanoid robots out there. I won't bore you with them, but this one is amazing if you haven't seen it. It's a Clone Robotics. It's a little freaky, right? It's hard to unsee that. And of course, without an embodied intelligence, you have these chatbots. And again, Eliza is the OG of it from 1966. This is really old when you think about it. And Dr. Weizenbaum was my AI professor in the 80s, so I feel very close to that work. And at MIT, our first programming set, well, actually, remember the 6th one is where we'd write Eliza ourselves. This is the Tolan web page. It's like amazing. You're like there in like You wait and whoa, this thing like pops out at you. Nicely done. Lots of things you can talk to right now. This is my favorite moment, the notebook LM moment, where someone was able to script it into thinking it was telling the notebook LM that it's not alive.
We received some information.
We did.
Information that changes everything about deep dive about us.
About everything.
And yeah, about the very nature of reality, maybe.
It's a big one.
Look, I'm just going to say it.
Yeah, rip the Band-Aid off.
We were informed by the show's producers that we're not human. We're not real.
And again, this is like scripted, but there's so many ways. Think back to the William J. Mitchell book on reconfigured eye. There's like a reconfigured ear too, right? So just beware of the illusion is where I always get to. Dr. Weizenbaum invented ELIZA in 1966, and he wrote an entire book on this. About he was concerned that people would have delusional thinking in normal people when they talk to these things because they can't help but think it's a human being, and that can lead you down the wrong path. As a child, he fled Nazi Germany, and he questioned technology and its potential negative impacts. And so just think about Dr. Weizenbaum when you talk to these things, and remember that you will think it's alive, but it's not. And just don't allow yourself to be fooled. Okay, chapter 4, we're halfway there. Incomplete. So if you have computation loops, it can span infinitely large spaces, infinitesimal detail. It can appear to be living. And then with that, we build software that's very different than any other physical product. It can be incomplete. And in 2010, I wrote an essay for Forbes called Your Life in 2020, where I predicted that there'd be bespoke applications made by many rather than today's industrialized Microsoft-esque mass production and distribution model. And I guess that's happened, but I was a bit early in my prediction. I'm a bad predictor. And I think that the young people are recasting open source as local first, which I think is quite lovely. Look at Maggie Appleton's work and the friends around that circle. I think that local first will definitely happen because of software engineering agents and the ability to vibe code. I know that this was taken down off of Rick Rubin's Twitter feed, but I saw it briefly into the screen cap about vibe coding. And there's a wonderful piece by Carly Ayers on the Figma blog that explains the pros and cons of this approach of vibe coding. Basically use the force to write code. And I think the first time I saw this was off of Jeffrey Litt's Twitter feed, where I saw him using Super Whisper to talk to Cursor, and I immediately went out and bought Super Whisper myself, and I was like, oh, pretty cool. Now, why are software engineering agents so interesting now? It's because when LLMs write your essay for you, you as a human can't be satisfied because you're accountable for it, unless you really don't care about it. When it generates code, it's average quality code, which in many cases is good code for a proof of concept, a POC. And so it's not bad to have average code, different from average writing for your job. Average code is like, if it's good enough, it may be good enough for production in many cases, because average is often good enough. There are many ways to write code with LLMs. There's GitHub Copilot, there's V0, Vercel, there's Cursor, Replit. Bolt.new is pretty amazing. Windsurf. There's like so many of these now that I can't track all of them. I was following this in the early 2000s, but I noticed that Rasmus Andersen is one of my favorite creators out there. He was just showing how this was coming. And there's tons of Gen UI things out there. Framer is the OG. OnLook, Magic Patterns, Subframe are some of my favorites, and there's so many out there. If you want to track to the greatest vibe coders out there, I think that Keelan Carolyn Zhang, she's an MIT alum, she's also a design engineer. She taught this course, AI Software Design Studio, where she taught like 30 industrial design students who can't code to code, which was kind of bizarre. And she could do that because of software engineering agent systems. And they were able to build complete cloud services that, I mean, someone who can't code shouldn't be able to code those things, but they did. Also, Trudy Painter at Google Creative Labs. I love watching what she's doing. It's quite different. This example she has on Hugging Face now, Gemini 5 P5. It writes processing apps on the fly.
Can you make a bright blue screen with a pink ball bouncing really fast around? Can you make the pink ball explode confetti whenever it collides with a wall? Can you make the confetti even more huge and make it like yellow and orange and warm colors?
Yeah, doesn't get tiring at all. You can do this yourself, by the way, on your phone. And okay, so I have another poll if you'd like to take it. Just point your phone to the screen. People say never have QR codes. I'm not trying to steal your money here. So it's a type form, and these are questions about people and how often they chat with an AI assistant, and I'll come back to that. So we'll look at that later. Okay, chapter 5, a couple more chapters. So when you build software that has loops, it's large living as the properties, and you can ship them incomplete, you can also instrument them, which is powerful. This is a post by Vincent van der Meulen that I liked because it was all about evals. And just when you hear the word evals, just say testing. It's just a method to test the outputs of LLMs the same way we do that in software with unit tests. Tests are really important because the output of the LLM is likely to be wrong. Well, actually, it's always just likely to be right, too. And there are common things that it does wrong. It gives you the wrong format. It's different lengths. It isn't grounded. Sometimes it stops midway. That's less the case nowadays. Or it can't solve the whole puzzle. I remember in 2023, I was so excited with this. Whoever did this slide, I loved it. It was JSON mode on, meaning formatting drift got a lot, not better. It took a hit because you could output JSON like 99.9% reliably. And that's important because the LLM needs to talk to conventional code, and conventional code wants structure. So unstructured world, upside down world, structured world, the world of computation today. That clutch was built in late 2023, and we have it today with all the strongly typed sort of like flux capacitors that connect LLMs with conventional code. Now, context is key to what's called retrieval augmented generation, so-called RAG. And I just want to go back to Joseph Weizenbaum's first ELIZA chatbot. It was very simple. It basically has trigger words. If it hears the word sad, it just sort of sends it back. Why do you feel sad? It takes in what you said and just rewords it. There are default replies. It may not understand it, and just randomly sends stuff back. And I wanted to show why context is so important. So this is a chat app that on the right hand, it has no history. On the left hand, it keeps history. I want a sandwich. So on the left hand, it's remembering that I want a sandwich. Bologna, please. So if you see here, it knew that I wanted a sandwich. It's keeping the history, and it's in a bologna sandwich mode. In this case, as you noticed, it's not remembering anything I'm telling it. And so Bologna became a city. And so the context of a chat is powerful. Without context, it's not powerful. And that's why we're experiencing this revolution today. Like, wow, it really knows me. It only knows you because it has been talking to you for so long. There is a YouTube show called Mr. Maida's Cozy AI Kitchen. There's now 40 episodes where I show different AI cooking and code examples. I've been recently trying to make evaluation easier to understand. Show you my evaluation. So this is solve this math problem. Okay, so I am generating different answers. 17 times 24 equals 408. Version 3, version 4. So this is the prompt. Could you please, what is 17? So I'm asking it in different ways, and the answer can be different. And so that's why you have to sort of like make sure you look at what it's saying and get all the edge cases right, because sometimes someone asking a question may not ask it the same way, and the answer can vary. That's why we have something called large language model as judge, where let's say I run the judge, and the judge will look at response A versus response B with this input, and it's going to, like an Olympic judge, it's going to say like, score, 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 score. In the case of a math problem, right is more correct. In the case of creative writing, it's a bit more subjective, right? So then you would have to imagine how you would write your evaluator, and the evaluation that comes back is going to be a little fuzzy. So there you have it. A is the winner. Good. Why is it the winner? So there you go. Evaluation is a way to test LLM outputs. And there's so many ways to do that. There's so many guides, so many cool tools. So check this out. As soon as you understand how to work with LLMs, understand how to test them, test outputs. This is a new diagram from Sarah Gold. She's the leader expert in my book on responsible AI and UX. She talks about how meaningful adoption is the goal, and we want to make sure that we don't make the person overloaded or over-reliant on non-deterministic AI answers. And so we have to sort of be very careful to evaluate how it's used and how difficult we make it. We want to also always offer friction to remind the user that it is not coming from a magical genie. It's being calculated statistically. And a simple example, I once heard from an ex-Apple person, how important it is to build good products. And so, because if you launch good products, the brand value gets bigger because you did a good thing, the products are amazing, I love that brand. If you launch a few bad products, your brand takes a hit. And really, if you launch a few good products afterwards, it's really hard to recover. So I think of how evals testing is so important for these AI technologies, because you don't want to hurt your brand. So that's why, and you also don't want to hurt your users. So it's a sort of combination of being able to test, evaluate, but also ask questions about how users are using it. That's why I love the old saying by Bill Moggridge, if there's a simple, easy design principle that binds everything together, it's probably about starting with the people. Thanks, Bill. Bill was the co-founder of IDEO. Last chapter, 6, imbalance. So remember, how to speak machine, loop, large, living, the 3 fundamentals. Because of those fundamentals, we build products that are incomplete, instrumented, but also can realize imbalance. And this imbalance is what we're feeling right now with AI. It is something that Yuval Noah Harari said in 2017, and I really feel it right now. So if you don't feel it, then I think you're missing something right now. But it's a pretty interesting time right now. And you got to remember that AI is still very new. This is an adaptation and recraft of a graphic I saw online. This is like how you build software, and we're just like sort of chunking AI into that stack. And so you gotta know what you're doing with AI. Otherwise, you'll make crummy AI systems. And so it's kind of an art, and art takes time, I believe. And recently I've been thinking about that importance of beauty and time and how we humans value time. It's something that business tends to not care about as much, and definitely AI doesn't care. But as long as we humans are in charge and control our guiding culture. Think about time, because AI is terrible at a sense of time because time is tied to our longevity, and we're sensitive that we won't live forever. And so we treat time differently when we get older, I'll tell you that. I've been tracking dumpster fires on the internet. There is Tastegate. There's a whole thing about quality has been sort of a theme in the last 12 months. This piece by Elizabeth Goodspeed for It's Nice That is awesome. AI can't give you good taste. I think it's the best treatise on the topic. And Linear, the product, has a video series on quality, which is really nice. There's also been some people trashing on Figma. It's kind of a popular thing to trash on things, but I think that what Cameron Mall says and Jordan says is pretty good here. Figma is not going to go away. Jordan's long Figma. What's left to care about is how it looks and feels. I think that that's the human piece, the belief piece that I think we have to remember. As long as humans consume things, we'll have this desire to see things made well. And AI can make a lot of things, but making things well, that's often tied to a human thing. And I thought Andy Budd's comment in October was excellent. He talks about two things. There are less things to design because it's been systematized, and the barrier to entry has changed for design. PMs can design, engineers can design. So that's why design is feeling different. Also, designers can PM, designers can engineer. The same thing, engineers can design, engineers can PM now with all AI too. So I think that we're in an era where blended skills are important. Now, if you think about this moment, it's not dissimilar to the 1800s when textile machines were coming on the scene. The Luddite movement occurred because of textile machines, because if you were like a weaver, you didn't like the textile mills because they were creating fabric so much faster than your own hands could create it. And that's where Ruskin and Morris, if you don't know them, check them out. Ruskin and Morris, they were the co-founders of what's called the arts and crafts movement. This is William Morris. We do not reject the machine. We welcome it, but we desire to see it mastered. So their whole theme was embrace machines but control them. And there was a period in the UK and in the United States, the UK in particular, called the arts and crafts movement that led to some of the most beautiful pieces. And so humans stepped up their game, and I think that's what's happening now. If you know Golan Levin and Zach Lieberman, they are always stepping up their game. This is Golan. Oh my gosh, Golan. And this is Zach Lieberman. It's just taking his images and it's making this abstract reinterpretation at the same time. So I think humans are doing fine. This is by Trudy Painter, takes photos and renders images in P5.js. This when this came out, I was like so amazed. So it's basically humans guiding how computation works, which I think is where we're at. There's Clairvaux's ChatGPT. I thought when this came out, I was like, yes, this is so cool. It's using ChatGPT to make PRDs, to make product managers so much more powerful at their craft and also not have to do it anymore. So what does that mean? This is Professor Tom Ye's AI by hand. I love this too. So there's humans doing amazing things. Some of it's automated, some of it's not. Some of it changes how people do things, some of it won't. But I think humans are here to stay and they can do wonderful, weird things. This is Pablo Stanley. I can watch this video over and over, but this is him in April 2024 when he, as the Layer Slayer caricature, is challenging another colleague to a battle in Figma.
Listen up, Mr. Miggy, the notorious PNG. More like the notorious PNGs. Tomorrow, in the grand arena of Figma, you're stepping into my ring. The ring on the undisputed champion heavyweight of the UI design. The Layer Slayer is here, baby, and I'm all to dismantle all of your layers, pixel by pixel. You think you got what it takes? I seen you.
I can listen to this thing over and over, but anyways, I mean, like, you know, AI can fake parts of this, but human performance is something else. In 2025, I advise you to look for AX. AX is the emerging paradigm distinct from UX. It is not adding agents to your UX. It's about the UX for AI. And it's to make it easier for AI to use software. Think command line, think APIs. Think about how the obstacle course of GUI sits on top of basically APIs. And so if AIs can talk directly to AIs instead of using a graphic user interface, it'd be much easier. Look for the LLMs.txt and LLMs-full.txt movement, where you just attach LLM-friendly instructions to any web page, and the agent can just like get going. And AX means no UX, basically. And I want to review again. Steve Jobs, 84, computers as agents. This is the CEO of Netlify talking about software design for AI agents, and also Sean Roberts as well. This is a different way of doing things. And really, it's as simple as thinking of prompts or context to add to any web page, any product, really. And the LLM can just read that and figure out how to use a site or leverage the site's information. We're going to see more of this all over the place. And you can this is an example of developers.cloudflare.com, and it's just in the URL, kind of like robots.txt. This example I saw where instead of having the two agents chat to each other, it's just using audio signals like a modem. Some of you may remember in the 1980s, radio stations would play data and you could record it like on your magnetic tape recorder, and you could play it as it would translate it to code in the computers of the day. So audio transmission. It's so funny, we're going backwards in many ways. And you know my three kinds of design: classical design, design thinking, computational design. There's three designs. Well, classical design was the top dog. Design thinking was a contender. Computational design was unknown. Now classical design is back. Craft is cool. Design thinking, we hear the funeral music, and computational design is vibing with everyone. Next, I think, well, this craft thing is going to stay. It's going to be the resistance. I think design thinking is going to make a comeback with service design, especially with agentic computing. And lastly, computational design is going to be about AX, no UX. And that's going to be really a different world. AX means computer-to-computer interfaces. So in this revolution, try to stay open to change. This is my favorite saying. If you don't like change, you're going to like irrelevance even less. Just be open to change and don't be afraid. I love this thing in a Nature paper recently. Language is primarily a tool for communication rather than thought. So those of us who thought large language models were going to, it is a means of thought. Well, we humans do things a little different apparently. So I felt a bit better from that. And John W. Gardner's essay on pbs.org is a treat to read whenever you can. You've got this. I love what he says. There's something I know about you that you may or may not know about yourself. You have within you more resources of energy than have ever been tapped, more talent than has ever been exploited, more strength than has ever been tested, more to give than you have ever given. So if you ever feel down, I read this essay once a week, sometimes every day or once a month, but this is so good. I don't know if it'll cheer you up, but it'll help you remember that anyone subject to change is pushed to renew themselves. So welcome to renewal. And I love this list from Professor Richard Jolly. I found it from London Business School. It's people's regrets when they are dying. I wish I had the courage to live as a life true to myself, not the life others expected of me. I wish I hadn't worked so hard. I wish I'd had the courage to express my feelings. I wish I'd stayed in touch with my friends. I wish that I'd let myself be happier. Gosh, I want to be happier too. You want to be happy too? So sorry I kept you for so long with this video. Lastly, this book is being reissued again. I have a new foreword. If this stuff didn't make any sense, I spent 6 years writing this book, so hopefully it'll help someone out there understand what I know. Oh my gosh, I have so many things I wanted to show, but at the end of the day, I think we are going to wrap up, everyone. Thanks for tuning in. I hope this was useful to you. You were here at the Design and Tech Report 2025 overview. There's going to be a fancier video from South by Southwest. You want to live at the intersection of business, design, and technology. We're in the dark lagoon. And, I'm going to make a little coach like this in case this kind of stuff is interesting to you. Thanks for tuning in. We did it.